Hi friends, welcome to my YouTube channel Computer Vision Freelancer. You're watching this video means I think definitely you will connect somewhere to the generative AI. Then definitely you will had this word agent. So in this video we will decode agent. What is agent? What is LLM? So what is the use of agent, and we will see how agent flow works from scratch. First of all, in the fast growth of generative AI, LLMs are so capable, they can do so many tasks. But if you see, an LLM is trained on some large amount of data. If we ask questions related to latest things, or questions related to personal data, and the questions which are not in the training data, then LLM will fail to answer the correct solution. So that is the main drawback in the large language models. But just imagine if you help LLM little bit to make it little intelligent and answer the questions. That is what agent. So we are bounding some sources, and in generative AI we call it as tools, some tools with the large language model, and make it as intelligent agent. Now it can answer questions based on relative real-time queries. So finally we will create agent using LangChain and also LangGraph. Let's dive into Colab. So we will implement here in Colab. First, if you see in LangChain we have something called chart models. So LangChain will support so many LLMs. You can see here the list. So here in this video we will use ChatGrok. So this Grok was a open source platform which will give free API. We can use so many LLMs through this API. So after seeing here ChatGrok, you can observe here tool calling. So what is this tool calling? So it shows that these models will support tool calling. So what is this tool calling? This is the main important thing in the agents. So tool calling is nothing but if you ask a question to this model, if it don't know the answer, it will give empty text response. But in the result, in the argument of tools, it will give the name of the tool which we have to call to get the answer. So itself, the model choose itself, it decides itself which tool to call. So that is the simple intelligence to the model. That is what tool calling. So in future you will know how this simple thing will lead us to create big agents, intelligent agents. So if you see here ChatGrok, it has tool calling ability. So we can use this model, this ChatGrok models in this video. So okay, let me see next one. So now you know this model will respond an argument of tool name. Then the question is, what is the tool? It's the simple question, what is the tool? If you see, LangChain supports the creation of tools from functions. So simple function can act as a tool, and also LangChain runnables. So if you see what is LangChain runnables, in LangChain we can make everything as runnables. So each runnable is able to take some input and give some output. So what we'll do in LangChain, we will join these all runnables with the chains, and finally at starting runnable take the input and the data will flow through the chains, and at end we will get the output like template as a starting runnable, LLM as a middle one, and output bars as a last one. So we can get a chain of connections. That is what LangChain, how LangChain works. So we can make another video on how LangChain works, and also we can by subclassing from base tool we can create a tool. So here the beauty of tools, here we can use a machine learning model in that function, or we can use a deep learning model, or we can use simple logic. That is what custom tools. So we can make the tools, and we can bind the tools to the LLM, and we can use those machine learning, deep learning knowledge along with the LLM. So that makes our application robust and intelligent. That is what the beauty in the agents. And if you see, simply we can create a tool by using just @tool decorator. We can use this tool decorator, and we can create this method multiply. So now this method multiply is a tool, and we can create tools, and we can create the schema of the tool from base model identic. So and it shows that the field values, like in the tool, what the input values given to the function. So if you see, and we can create structured tools, and also create tools from runnables. If you observe here we have prompt, LLM, and output pairs. So this prompt, we are getting this from chat prompt template as one runnable in LangChain. So it will take input, so and it will generate some output, which is what the customized prompt given to the LLM. And this LLM is a one runnable which takes direct input and give output, and this output pairs. So if we will chain them all three together with this symbol in LangChain. So now we have a chain. So simply just chain dot as tool, we can make this chain as a tool. So we can use this chain as a tool. Finally, we can use single runnable of a LangChain as a tool, and also whole chain as a tool, and also subclassing based tool. We can create custom tools. So here we can create so many custom tools. So now we know what is tool and how to create a custom tool, and we can use so many machine learning, deep learning models in the tools as a custom methods. So we have so many tools, and we know the knowledge of tools. And so we know how to create a tool. So and also we know tool is itself a runnable. So if we ask a question to the LLM, intelligently it will call one tool. So in output we will get just name of the tool. So by taking that name, we will invoke the tool, because tool itself runnable. So by taking the name from the LLM, we will invoke the tool, and after invoking the tool we will get output. Then the question is, why we need LLM? Just to give the name of the tool. So the thing is, after getting output from the tool, we will again pass that output to the LLM. Now LLM have some information, depends on that, and according to our question it will give answer. So that is the agent. So we will see how this flow works. So this circle flow we consider as agent, LLM, tools. So if you see here, from LLM we will get the name of the tool, get weather. So after getting that name from LLM, we will invoke the tool, that is called search tool. After invoking the tool, we will get some response from the tool. Now this response again will pass to the LLM, and it will generate the answer according to our question. That is the flow. So now we are using Grok, so open source. So if you see here, Grok, if you see Anthropic, okay, it is not working. So here just we have to install LangChain Grok. So LangChain have this compatibility with Grok. So just go to the collab and paste it. So in the meanwhile, just go to Grok platform, Grok API. So after going here, so this is the Grok platform. They are using something called LPU, which is faster than GPU, so they will provide faster inference of the models. So here there is Grok API. Go here, after logging into Grok platform, you can see here API keys section. So create API and just enter name for the API. I'm entering agent, and after submit you can get an API. So yeah, here it's installed. I'm just pasting my API here. So don't use this API because I'm deleting it after the video upload. So if you go to here in this section, you can see from this LangChain grok we can import chat grok. So this is the chat grok. So using this module we can load the model, and so here we are loading llama 3 8b 8192 from grok. So here we have LLM, just run it. It may not work. See, it's asking API key. So we will do, we'll enter API key. This you can directly enter here, or we can pass it from as in local variable. It's our choice. Yeah. So after running this, see our model was loaded. So and next step, see, so we have LLM, and now what we want, tools. So as of now just create 2 custom tools. So as I mentioned before, to create a custom tools we have so many methods. Just I'm using this tool decorator as I just import that tool and go to here, just copy this. See here I'm using this tool decorator and creating 2 methods which we call it as tools, one for addition and next one for multiplication. So here we have to note one thing here in agents. The main thing was, wait, I will show you. Yeah, while constructing an agent you will need to provide it with a list of tools. We have to provide our tools as a list of tools. So remember this. And so see here we created 2 tools, one for addition and next one for multiplication, and next we are making it as a list of 2 tools. So after making list, so I told you that we have an LLM. If we ask a question to the LLM, it will intelligently finds which tool to call to answer this question itself. So to get that knowledge, we have to bind our tools with the LLM. Otherwise our LLM was a normal LLM model which try to answer to our question without thinking about tools. But if you bind the tools with the LLM, then, and this LLM already have tool calling ability, we already checked it. So now it has the ability to call the tools. So just run it. Yeah, now we have LLM with tools. And next, if you see, I'm just trying to ask a question. See, the question is what is 3 multiplied 2 and also what is 11 plus 49. So here I'm asking multiplication of 2 numbers and also addition of 2 numbers as a question. So first you can observe, I'm asking this question to the LLM with tools. See, if I print the response, our LLM response directly here, underscore message, you can see in our LLM response the content was empty. So our LLM doesn't provide any answer, but what it do in the tool call argument, it gave the name of the tool which we have to call. See, the multiply and also next one addition, add. So it tells us to call these 2 tools here. So I'm printing the tools also. Here we can see the name multiply as a one tool, and every tool has ID, because by taking this ID only we will know this was the solution, this was the result from this tool. And addition, so these 2 tools was called by this LLM because we are asking the question. These 2 questions are closely related to these tools. So the LLM intelligently calls the tools instead of giving a answer directly. So So the first step in the flow happen. And next, if you see, so now we know which tools to call, and we already know every tool in LLM is itself a runnable, so we can directly invoke the tool. So now we are doing that. So we are now, see here what we are saying, we are from tools, we are just lowercasing the tools, and we are, see, we are have add and multiply. If the tool was add, then we are calling add tool. That is what we created two tools, add and multiply. So we have add as a string, then we will call add tool, and multiply as a string, we will call multiply tool. So after calling the tool, and we will invoke the tool, because tool itself a runnable, LangChain runnable. So we will invoke it, and we will get the tool message, and we will append that message to the message list, because we are storing this whole message as a sequence of conversations. So now I run it. See the message. First we ask this question as a human message, what is 3 into 12, and also what is 11 plus 49. So for this human message, the AI LLM gives empty result, but it calls some tools. So what we will do, next we invoke these tools, and these two tools gave some response. See, tool message, one tool gave content as 36, multiply tool, because if you multiply 3 into 12, 36, and next tool, which is add tool, gives result of 60. So if you add 11 plus 49, it was 60. So we get result. Here in this case, we are created custom tool, it directly gives the answer. But most of the time, if the tool was a RAG retriever, it will just give us some bunch of text, or if the tool was a search engine, here it will just give some information. So that is not our solution, because we ask our question to LLM, so LLM has to answer, depends on our question. So again we have to pass this message to LLM, that is the goal, then the circle will complete. That is what agent. So if you see here, again we are invoking, because here after bounding our LLM with the tools, LLM itself a runnable, LangChain runnable, so we are directly invoking the LLM with tools with our final message. If you see here, then it will answer the question. See, the answer to what is 3 cross 3 is 36. So it will answer in such a way according to our question. So then that is the reason why we want an LLM at end. So now the circle completed. The whole thing we call it as agent. But here we have only two tools. We may have 10, 20, 30 tools, and in the tools some of the tools may be search engines, some of the tools may be RAG retrievers, and custom tools. In some custom tools we can use some computer vision algorithms and models and deep learning models, so we can make intelligent agent. So this is the flow in the agent, how this circle happens. So, and next, okay, now we will build a real world LangChain application, which was agent, real world agent, using LangChain. So if you see here in this example, they build an end-to-end agent. They are using chat Anthropic, but now we will use our open source free chat Grok, and they are using this Travelly Search as a tool for searching. But we will use some document RAG information, RAG retriever as a tool, because we want to make an agent. So we are not following this, we are taking reference from this. If you see, these are the packages they install. So LangChain community, LangGraph, Anthropic, these things. So let me install these two. Here. So in the meanwhile, we can see here, I will show you one thing. Yeah, here in agentic RAG, here this is the source. So here they created one agent, one tool from a retriever. So first we will we'll copy this. So it installed. Can go here and we paste it. So if you see, these are the documents. These are the posts on agent, prompt engineering, and these things. So we can get these 3 URLs, and from these URLs we will get the data, and after we got the data, we will make the data into documents, and we will use recursive text splitter, split the documents into chunks of size 100, and after that we will convert this text into vectors. So here they use chroma db, and after that we will convert this retriever as vector store as a retriever. After converting this vector store as a retriever, this retriever was a LangChain runnable again. So that is the thing. So we will try to get some packages except OpenAI embeddings. So here we don't read, we want some embedding techniques definitely, because first we have to convert our documents into chunks, into vectors, chunks and vectors. So we want one vector embedding model, but here they are using OpenAI embeddings, but we don't have API key of OpenAI. So we will try to use Hugging Face vector store retrievers. So we will use Hugging Face embedding models. So for that we want LangChain Hugging Face package. So we will install it. Because we are not using OpenAI, I don't have OpenAI API key. So after pasting it here, so we are installing LangChain Hugging Face package. After that we are using this LangChain for converting the documents into vectors. That is the basic thing in RAG applications. So after remove this OpenAI embeddings and paste this Hugging Face embeddings, and after that so then use the example, just open it. So see here they have one model, Hugging Face embedding sentence transformer model. So here we will use this. So embeddings, and after that so this is the text embed query. So we are calling that embedding model. Just try to pass this embeddings here, embeddings. So try to run it. So it will take the data from this post, and after getting the data we will convert the documents into a list of documents and chunks, and we will use recursive character text splitter, make it chunks of size 100, and next we will use this Hugging Face embedding model. So it is showing no module tick token, so just install it over here, and I can install it. Yeah, I'm doing this all in real time because you will learn how to do things like this only. So after this we will run it again. So the final goal is, so now we have a retriever and it's saying Hugging Face empty is not a callable. Okay, then if we go to here, so what I found is we don't need this Hugging Face handpoint. It's not using anything from Hugging Face hub. So we have Hugging Face embeddings. So we can directly call this here. We can directly call this Hugging Face embeddings model name. This was the model. If we run it, here we have recursive character text split. So here we do I didn't install this ChromaDB. Let me install this ChromaDB. It was a vector store because we want to store our vectors from the documents. So we required vector store. So after that, from that vector store we will retrieve the related documents. So that is how retriever works. So here I am installing ChromaDB. So now it will work. It's taking a little bit time. If you have faster internet, it will work faster for you. Let me run this. So now the thing is, so we successfully created a retriever which was a LangChain runnable. So now the next step was we will convert this retriever as a tool. That is the main thing. So for that I'm using this code here. So here from LangChain tools dot retriever I'm importing create retriever tool. So with this, here I am giving the name for the tool and also description for which cases the tool has to work, because every tool must have some name and the input format and some description that helps the LLM to choose the tool effectively. That is required. So it's taking some time because we are converting this bunch of documents from the web into vectors and I'm storing that vectors in DB, and also we are converting those documents into vectors using this sentence transformer. From sentence transformer all MPNet base v2 model as an embedding model which was open source. Here in this tutorial you can see, in this tutorial they are using Travely as a tool which requires a Travely API key, and it was a search engine, but we are using just a retriever as a tool. Okay, we can use anything as a tool, and I showed before a custom function can be a tool. So here they created one tool named search. So we created a tool called retriever tool. So everything is same. So after that you can see we are using Grok model. This is the thing, LangChain Grok. Just me run this again. So Grok. So we already load the model Grok. We already have the Grok model because here in the before, if you see here, we already loaded the LLM from Grok API. So we already have the Grok. So we already have the model. We can directly connect with the model. If you want, I can run it. See, because we already loaded the model. It is taking a little bit time. Yes, it's completed. You can see we have our retriever. Now we are converting our retriever into a retriever tool. See, now we have tools. We have only one tool, and see we can call directly our Grok model. See, this was the response from the model. Like this, we got different response because we are using different model. And the important thing was we already know we have to bind our model with the tools. That is the main thing. But here if you see, they are binding the model with the tools, and same they are calling the model with tools and just showing what we did before. We got the model gives response as a tool name, and we will invoke that tool. That is what we already did before. Okay, so but here in LangChain we can use this create react agent method directly itself. So you can see note that we can passing the model, not model with tools. Here while passing we have to pass only the LLM, not the binded LLM, because in this create react agent method, it will do under the hood, it will do the bind tools inside. So we can directly use this. If you go here, so we want LangChain prebuild import create react agents, and we are just passing our LLM, not LLM with tools. And here we are not binding the tools also, because we already did that before. Here you can see, here we binded, see here, yeah, we binded our LLM with the tools. They are different tools, but here with this method no need to bind, it will do internally. That's what I'm saying. So yeah, we can directly run this. Now it became an agent, so I will run it. I will follow these steps to run the agent. Just copy this. I will show you how internally the same thing happening. See, if we run here, just we are asking hi, it is showing. See, if you ask a question about this blog post, because in our tool we mentioned in the description that such and written information about this blog LLM agent push. So if you ask anything about this type of question, what it will and see, this was our question and the response was empty, but it calls the tool name. You can see here the tool is the query and the tool, the retriever blog post. So that was the tool name, and so now it will call the tool, and automatically see we will get the tool message. So we will get some information about the question, and again it will pass, we know that again it will pass back to the model. Now see the model response. See, just I will wait, stuff response. Can go to last one. Let's see. See, this was the, just go to content. You can know. So this was the model response. It seems like the tool call ID written a blog post from the wing about LLMs. Okay, it is doing like this. Let me tell you that. See the AA message. The content was, yeah, it seems that the LinkedIn Beams has written a blog post. Yeah, this was the content. Okay, this was the content, AA content. We can know that content by just typing content. Yeah, so this was the response. So here this create react agent itself bind our model with the tools, and it invoke the tool, and again it will pass back that response to the model, and we can directly get the response here. So that is, so this method makes life easy while creating the agents. So you can follow this post again. See, here they ask hi and it will say hello, and after that they will ask something about weather in San Francisco or South Africa, something. And the thing is, see here the human message, and the AQ based on the search result. Here are the summary current weather in the San Francisco, something it got from the web, because the tool call was search engine. And we can stream the messages also like this. If you go here, we can see separately. Suppose, let me type this question. We are asking question related to the blog post, because we are using retriever as a tool here. Blog post tells me ask this question. You can see the chunk. See here, first the model gives nothing as a response, but it calls the tool. After that, the tool will start invoke, and we will get some data from the tool. Okay, and after that the Again, the LLM gives the response, depends on the data. See, it says something, it looks like Lehman has written blog post about adversarial attack on LLMs, something. So the whole flow happens easily just using this create react agent in LangChain. So this is the one way in creating the agents. Okay, next, if you see here, we can stream the tokens. You can see here we know how many tokens token wise, so these are the each token, so we know how many tokens are generating. And also we can add memory. The thing is, if we chat with a model and we will give some information and we will chat for some time, and again next time if we chat with the same model, then we cannot introduce ourselves to the model ourselves to, or we cannot introduce the problem to the model again. It must have some knowledge about what we discussed, what we asked past. So for that reason we have something called memory server. We can use this. Now we can show how to use this. It will store the past conversations. We'll see that how it works here. So we created a object of memory. And next, so while creating our agent, in before we passed only model and tools. Now along with that we are passing something called checkpoint. See, our model is our LLM, which was from chat croc llama, and tools are the retriever, and this check pointer is this memory object. And now we will create one config, one thread key. We will make it something called 1 as a thread ID. Run it. If you see here, just we are trying to make a conversation with our model. See, we are asking, hi, I am Bob.